Hello everyone, welcome back again to Geospatial Tube. Today I'm gonna show you how to generate lithology map or geology map to compute landslide susceptibility for Kaokoisha Orada. Before we go to the practical session, I would like to remind you to subscribe my YouTube channel, and if you have any question, don't hesitate to put down on the comment box. Let's get started. As I have mentioned earlier, today we'll give a special emphasis how to compute or generate lithology or geology map of our study area. First of all, we need to download lithology or surface geology from USGS. I'll put the data on my Telegram channel. If you are interested, you can download and use it. So this is the general lithology map of Ethiopia. First step that we are going to do is we need to extract on the basis of our study area. To perform that, let's go to view. From view, there is geoprocessing. From geoprocessing, let's select the toolboxes. And the step that we perform here is that we need to extract out on the basis of our study area. Our study area is a Woreda boundary. Let's have a look and zoom to layer. This is the administrative unit, and we need to clip out based on our area of interest. So from the available toolboxes, scroll down and go to spatial analysis tools. Here there is extraction. From extraction, we need to use extract by mask. The input raster dataset is a larger one. In our case, the geology map of Ethiopia. And the input raster or feature mask layer is the area of interest. So let me select the Woreda boundary. We need to give our output name. First of all, you need to have a working directory and save your output. Let me give a name as lithology, or you can say geology simply. Geology. Then hit run. Automatically the raster dataset is extracted on the basis of our study area. So from the available parameters that is considered within lithology in my study area, there is three basic geologic features. There is silicic, extrusive volcano, volcanic ash, tuff, and mudflow. So let me remove the larger dataset since I am focused on the dataset which is found on my study area. So at the map indicators, this area is silicic, whereas the majority of the area is covered by extrusive volcano. As you know, volcano is very common within the Cenozoic era. There was volcanic activities, mainly called the Trapian lava sea and the Eden lava sea. There was the active volcano, whereas the southern tip of this study area is covered by a volcanic ash and tuff of mudflow. So once we clip out our geology map, what we are going to do is we need to reclassify on the basis of the contribution for landslide susceptibility in my study area. To do that, let's get back to our Excel sheet and let's refer the geology class. This is the dataset that is related to the attribute table of the surface lithology of Ethiopia. So carbonate rock is mainly, the rock type is limestone. As you know, there are three types of rock: the igneous rock, the metamorphic, and the sedimentary rock. So the rock structure have its own contribution for landslide in a certain area. On the basis of this, we should consider the susceptibility class on the basis of the property of rocks. So in our case, we do have three categorical classes of lithology or surface geology in my study area. The first one is silicic, extrusive volcano. The 19 is volcanic ash. So 6, 9, and 19. 6 is a silicic rock. Silicic rock is mainly rhyolite, diotite, silicic intrusion. So This rock is characterized by hard, resistant to weathering, low permeability. So, since the silicic rock is characterized by hard nature and it is very low susceptible for landslide, so we need to use this silicic as one. One means very low susceptible. Let's search out extrusive volcanic rock. Let me explain what does mean extrusive volcanic rock is. Extrusive volcanic rock is a rock which is formed within the intrusion of magma to the surface of the earth through vent, and extrusive volcano is mainly characterized by a volcanic intrusion and it is flow over the surface of the earth. Such extrusive volcano is mainly characterized by basalt, andesite, lava flow, and the like. So this extrusive volcano is also strong, but can weather over time by using the chemical or physical weathering process. So this is the low susceptible. Then for low susceptible, we use 2. The final class that we have in our study area is 19, volcanic ash and tuff. Let's have a look. 19. Volcanic ash, as the name indicates that it is volcanic ash and there is a mud flow. This material is very fine volcanic materials and they are loose and consolidated and it is very high susceptible for landslide. So we provide 5. So on the basis of this criteria, silicic rock is very strong, so it is very low susceptible and the value is 1. Extrusive volcano is more, it is low susceptible, we provide 2, and the final one is highly susceptible. Let's get back to our ArcGIS Pro and let's reclassify this. To reclassify, let's get back to geoprocessing and from spatial analysis tool, we need to select reclass. From the reclass, scroll down and click reclassify. From the reclassify, the input raster dataset is geology that we have clipped out from the larger dataset. We do have 3 classes. Silicic is classified as, let me reclassify 1 to 3 and I'll give it within the attribute table. So 1 to 3, 1 is silicic, 9 is extrusive volcano, 19 is volcanic ash tuff and mud flow. So this is our reclass. So open attribute table, right click and let's open the attribute table of our geology data. Let me add the field. The field name is, let me give us weight. Weight is a numeric, so short integer, the data type is numeric. Then hit OK, save it, and let's get back to the main attribute table of our data. So I have added silicic is very low susceptible for landslide, so the value for silicic is 1. Extrusive volcano is 2, and volcanic ash tuff and mud flow is 5. 5 means very high susceptible, 2 is low susceptible, 1 is very low susceptible. After once we set the lithological class on the basis of their weight, it is visualized by making symbology. So go to right click and go to symbology. From symbology, we do have a unique value. The field is weight because I have assigned the weight on the basis of their landslide susceptibility mapping. So 1, 2, and 5. 1 is area with very low susceptible area that is covered by the silicic rock, this area. 2 is extrusive volcano. This is low susceptible for landslide, whereas the southern tip of the city area is covered by volcanic ash and tuff mud flow. So this area is very high susceptible for landslide. So This is the way how to flip out and reclassify our geology data for computing landslide susceptibility. If you have any question related to this, don't hesitate to ask. Thank you very much.